This is an example of graphing a rational function when I may have a hole in the rational function, which I do for this one. And so identifying if there is a hole by factoring and finding out where it's at. And then the rest of which is a repeat of what we did before. So I want to graph the function f of x equals x cubed plus 2x squared minus 3x, all divided by x squared plus 7x plus 12. So the first thing that I'm going to do is I'm going to take the top piece and I'm going to try and factor that out. So I'm going to do that by clicking on the math piece. And I'm going to click down below here. Yeah, it still covers it up, and I can't move this, so it's best to write down the equation that you're putting in here first. Okay, so I'm going to factor out an x from everything, and that's going to leave me with x times x squared, squared, not 2, x squared, minus 3x, plus 2x, I have it written down, that's what I'm looking at, minus 3. Okay, now I can still factor. This is a binomial, which I can factor into two trinomials. I don't know what I'm talking about. Now, I can still factor this. What's in the parentheses here can be factored into two binomials. So this is equal to an x still on the outside, and then I'm going to have two sets of parentheses. And in the first parenthesis, I'm going to have definitely an x first. Now I got to decide whether I have a minus or a plus. So I want a positive 2, and I know that the factors of 3 are 3 and 1, and 3 minus 1 gives me 2. So I want a plus 3 here, and then I want an x minus 1 in the second one, x minus 1. So factoring was done in IM2, so you might want to review factoring before you try this. Okay, so now I'm going to check this. So I have foiling f times is the first, so x times x is the x squared, and then the inner is 3 times x, which is 3x, and the outer is a minus x. 3x minus x is positive 2x, and a positive 3 times a negative 1, the last one, is a negative 3. So that works out, and then this x would be distributed to make the x cubed plus 2x squared minus 3x. So that's, I have written out. And this is me showing my numerator, so I'm going to condense this down and put it right by my numerator. Goes into the graph, but that's okay. Okay, and then I want to factor the bottom. The denominator can be factored using two binomials because there isn't an x in all of them to take out. So I'm just changing the quadratic into two binomials. So I'm going to press math again. X squared plus 7x plus 12 is at the bottom. And I'm pressing on the screen. So this is going to be the parenthesis x plus 7x squared plus 7x plus 12 is the equation. And 12 is 3 times 4. And 3 plus 4 is positive 7. So this is going to be x plus 3. And it can be x plus 4 first. It doesn't matter. X plus 4. And so that is factored. And I'm going to put that next to my denominator. Okay, and this is my end piece. So I'm going to put it right underneath here. Okay, you can see, and from the videos prior where it talks about the whole, the x plus 3 can cancel out because it's the same on the top as on the bottom. So that means that you have a whole at x equals negative 3. Okay, at x equals negative 3, because x plus 3 equals 0 gives you that x is equal to negative 3. So I'm going to put a slash through that to say that these cancel, and my whole is at x equals negative 3. But I can't graph that until I know what the y value is. So I'm going to just write x equals negative 3, and I'm going to find out my y value for my whole. So if I plug in a negative 3 into what is left here, I would have a negative 3, and now I'm just going to use the texting. So I'd have negative 3 times a negative 3 minus 1 is a negative 4. And then this is divided by negative 3 plus 4 is a positive 1. So I have divided by a positive 1. So negative 3 times negative 4 is equal to a negative 12. Divided by a positive 1 remains a negative 12. So my y is negative 12 when my x is negative 3. And that's going to give me my whole. Y equals negative 12. Okay, so then to draw the whole, I'm going to click on these, click on the circle, and where I see negative 3, negative 12 would be down here, and it's actually not on my graph, so I'm just going to extend my graph. This is going to be 11 right below, and then 12 would be right below that, so I'm going to make a hollow circle there. Okay, and that's my whole. All right, now identify my vertical asymptotes. I've already got it factored, and the x plus 3 is gone because that's part of the whole. So my only vertical asymptote is at x equals negative 4, because I set that part equal to 0. So x equals negative 4, I want my dashed line. And here's my line and then arrow. Okay, so at negative 4, I have a vertical asymptote. So it's going to go up at negative 4 and down. I'm going to extend it all the way down because my hole is down there. Okay, now I want my horizontal asymptote. If I look at my degree on the top is a positive 3. I don't want dash line anymore when I circle this. So I'm looking at the, oops, nope, erase that. So scribble, and I'm looking at the 3 here, and I'm looking at the 2. And the top is the M, and the bottom is the N. So plot the points, or compare the degree of the top and the bottom. So the top is bigger than the bottom. Okay, so that means that I have no horizontal asymptote. Now, when you don't have a horizontal asymptote, you have what we call is a slant asymptote, and it's not bad to find it. So I'm going to find it here, though you are not going to be finding any slant asymptotes in the work that you do. I just want you to be aware of it. Okay, so I am going to take this top part and I'm going to divide by the bottom part, and in long division. So if I have, and I'm going to use the math, x squared plus 7x plus 12, and this is divided into, so I want that printed out. I'm just going to do it over here, and this is divided into, and I have this part, my top part, is x cubed plus 2x. I use the arrow to say that I'm coming down from the cubing. So this is plus 2x squared, and then minus 3x. So this is going to divide it into this, and so I'm going to make my division sign by scribbling. So I have my curve and my line, and so I start with the first term, and I say, what times x squared gives me an x cubed? And the answer is x. So I put the x up here, and then I take x times 12 gives me 12x. So I have 12x. Long division was also part of IM2. 7x times x is positive 7x squared. So I have a plus 7x squared. And then x times x squared gives me an x cubed. Now, the key in long division is that you change the signs and then you add going down. It's like subtracting. It is subtracting, but I do it in a different form. So this is 0. This gives me a negative 5x squared. And this gives me a negative 15x. Okay, what times x squared gives me a negative 5x squared? The answer is a minus 5. And when I put that down, I have a minus 5x squared. And a minus 5 times a positive 7 is a negative 35. X, and a negative 5 times a positive 12 is a minus 60. And then when I subtract, this is 0. This becomes a negative 50x. And I cannot go any further. This is going to have to be a remainder, because if I take my first term and I say what times x squared gives me a negative 50x, well, that's got to be a fraction. And I don't want a fraction in there. I would have that as the remainder. So my answer to my slant asymptote is that it is at x minus 5. And if I go to graph that, I know that negative 5 is my y-intercept. And my slope is a positive 1. So if I rise 1 and jump 1, rise 1, run 1, I'm going to keep going up. And if I go left 1, then I go down 1, left 1, down 1. So there would be my slant asymptote, and I can draw that in right here by doing dashed line everything okay. And then I'm going to do line and arrowhead. So I'm going to go this way, like that. And see, it's slanted instead of up and down or left and right. And that's where my graph is. Okay, now I need to know where this graph is on both sides. So I'm going to stop right